Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about 23 ECT 221 microprocessors and microcontroller subject under the topic 8259 interrupt controller. Based on my previous YouTube video, you may know how the 8251 and 8255 are interfaced with microprocessor. Now I am going to discuss a third and very important interfacing component called 8259 interrupt controller. So interrupt controller, or generally it is called as 8259. So this is the general interfacing of how this 8259 are interfaced with 8086 CPU. So generally NMI, INTR are the hardware interrupt pin that are mainly useful for any interrupt in microprocessor. 8259 or otherwise called as Programmable Interrupt Controller. This IC is designed to simplify the implementation of the interrupt interface in the 8086 or 8088 based microprocessor systems. This device is known as a Programmable Interrupt Controller or PIC. It is manufactured using the NMOS technology and it is available in 28-pin DIP. The operation of PIC is programmable under software control and it can be configured via a variety of applications. 8259A is treated as peripheral in a microcomputer system. 8259A PIC adds 8 vectored priority encoder interrupts to the microprocessor. This controller can be expanded without additional hardware to accept up to 64 interrupt request inputs. This expansion required a master 8259A and the 8259A slaves. Some of its programmable features are the ability to accept level triggered or edge triggered inputs, the ability to be easily cascaded to expand from 8 to 64 interrupt inputs, its ability to be configured to implement a wide variety of priority schemes. So this is the general 8 pins that are used in 8259 PIC microcontroller. The processor is interrupted whenever a interrupt service device delivers a signal to 8259. This 8259 uses 8 hardware interrupting devices that are supported by this 8259. So there are assigned signals using 8259. So if you see this left hand side, right hand side, that can be explained here. A D7 to D0 is connected to microprocessor through a data bus D7 to D0. IR7 to IR0, the interrupt request inputs are used to request an interrupt and to connect to a slave in a system with multiple 8259As. WR bar, the write input connect to write stop signal of microprocessor. RD bar, the read input connects to the IORC signal. INT, the interrupt output connects to the INTR pin on the microprocessor from the master and is connected to a master IR pin on a slave. INTA bar, the interrupt acknowledge is an input that connects to the INTA signal on the system. In a system with the master and slaves, only the master INTA signal is connected. A0, this address input selects different command words within 8259A. CS, chip select enables the 8259A for programming and control. SP bar bar EN bar slave program bar enable buffer is a dual function pin. When the 8259A is in buffered mode, this pin is an output that controls the data bus transceivers in a large microprocessor based system. When the 8259A is not in buffered mode, this pin programs the device as a master 1 or a slave. CAS2, CAS0, the cascader lights are used as outputs from the master to the slave for cascading multiple 8259A in a system. So next, this is the general block diagram of how this 8259A is looking like. So it consists of a very important of 5 important blocks. First block is the data bus buffer, where we connect a data of D0 to D7 to 8259 and 8086 microprocessor. Next, read-write control logic, where it can be used to communicate RD or WR. The next cascaded buffer comparator, which is used to communicate more number of